everyone to our demo. We are going to be showing today Cosmos running with CRUD, create, read, update, delete, using 4 validators. So we have Paul Archard here, and he's going to be demoing a swarm of 4 nodes running on the back end, running on multiple servers on the cloud. And on the front end, we have 2 pieces. We have BLZ CLI, which is going to be a proxy that acts like a light client, and it ensures that you have a BFT or Byzantine-Fault-Tolerant intermediary to ensure that the requests are indeed trustworthy. And then there's actually a JavaScript client that he's going to use to demonstrate create, read, update, and delete. So on to you, Paul.
Hi. Okay, so I've got 4 screens in front of me that you can hopefully see. These 3 on the top left one are 3 out of 4 of the nodes that are running. I've only got 4 windows, so I'm not going to show you the other one, but they're all doing fairly much the same thing. They're sitting on different hosts in the Amazon cloud. You can see their IP addresses up here, and they're all different. So each of these is currently running the Bluzelle daemon, which is doing all the back-end communication stuff. I'm going to switch across to a window that shows you the current status of the blockchain that's running on these things. So each of these nodes has a synchronized daemon running that they're all communicating with each other and sharing information on consensus and things like that. And they should all be effectively showing you the same information right now, even though they're different systems. And this is showing you what the current block height is over here. It's about 14,000 something. And it also shows any transactions that get committed within that block. And as you can see, these are all 0 right now because we're not doing anything. So on this side over here in this window, this is my local system, and I'm just going to start the REST server on this BLZ CLI here. What that does is it runs as Neeraj was saying, it runs a light client daemon, which runs on the current local node, which means it's running in a trusted environment. And then we use our library, our JavaScript library, to talk to that thing, and that then communicates with the remote nodes. So we have a very simple JavaScript program here called CRUD.js, and all it does is it basically pulls in the Bluzelle client library, which has got the backend, got the code that talks to the backend in it. It's very, very similar to what we had before, but it's different backend, obviously. And then it's calling some basic CRUD methods here to create keys and values, read them, update them, delete them, and stuff like that.
Okay.
So I'll show you some basic operations over here. And what happens based on them. So if we go to, first of all, I'll just create a basic key. So if I do CRUD.js create test key 100 test value. Okay, so what you should see here is in the current window, it'll show you the transaction it's building, and then the signature it applies, and then it will finally send that to the nodes.
Okay.
Okay, so it's built that and sent it, and then it gets a response back. And a few things you should notice here. We've got a valid TX1 in this particular block number that got executed, and this is on all of these nodes over here. They're all saying valid TX equals 1. So that particular block got submitted by the node that we talked to, and then the consensus was reached. They all agreed that it was valid. They all updated their state, and now the blockchain, that's committed to the blockchain, and now we have that state in our back end. Okay. So if now I do a read on this guy, I can show you that the value is indeed there, test value. This read command didn't go through any consensus. This is a direct read. It comes back with a proof showing that it's valid within the blockchain, but it only needs to talk to a single node in order to do this read, which is why it's so quick.
So that's what we call an eventually consistent read.
That's an eventually consistent read. It is possible to do a read that goes through a transaction process as well, but it's slower, so that's generally not what you would want to do, but you can certainly do that as well.
Sure.
So I will try and, I'll show you what happens if we try and create the same key as before.
Okay.
Again, this goes through consensus, but the result is a little different in this case.
Yep.
We now end up with a failure, saying key already exists.
Okay.
It's still a valid transaction as far as the blockchain is concerned. It just, the result that came back was not successful.
Sure.
So, so now if I want to do an update on that thing, I may as well go through all the various CRUD things. I'll change this to test value 222. Okay, and again, we're gonna have to wait for the block to be committed. Takes a second.
Yep.
But again, we've got our valid transactions on all nodes.
Yep.
And we've got our result that comes back here, which is telling us that it was successful in terms of making that change. So if I do a read now, it should have the new value, which is test value 222, which is, that's exactly what we were hoping to see. And then finally I'll do a delete on this thing.
And that's another transaction.
Comes through successfully. Again, it went through consensus and everybody agreed on it.
Yep.
And then if I do a read now, it'll say it could not read key because
try to update it. It should do the same thing, right?
Gone away. You can also just to sort of show the validators that are running in the background here, I can actually talk to the back end and get a list of the current validators and all their information. So we've got 1, 2, 3, 4 validators here, and it'll show you what current height is in the blockchain for those validators and what their address and key is. And all that.
So those are like a validator is like a farmer, right? So we have 4 farmers that are all participating. And where is the power list? Is that listed in this?
It doesn't look like it is. No.
Okay. So the power ultimately, even if it's not listed there, that ultimately translates to the stake, right? So if somebody has a higher stake, they would have a higher power, and that's how we determine voting power in our network.
Correct.
Okay, that's very cool. Now, what happens if we try to, you just deleted the key. What happens if we try to update it after it's deleted? I know you tried to read it. Will it give it the same error?
Do an update of the key after we've removed it? Like, okay,
yeah.
So I can try this. I'll try and update this again. It should just say key not found, I assume.
And it does. Okay.
Exists, so.
Okay, very neat.
So that, all the basic CRUD operations.
Yeah, so it looks like, just to summarize, I mean, I'll kind of summarize it and I want to make sure this is correct. So right now what we have is a truly trustless BFT compliant swarm of 4 nodes, 4 farmers that are running that support CRUD. And what you've just demonstrated is a client that actually talks to that swarm and can perform all 4 of create, read, update, and delete.
Correct. It's a very simple JavaScript program that talks through our standard API. Our library code does the translation and everything like that, and then it talks to the swarm in order to do the operations.
Okay. Well, thanks very much. That was really great, Paul.
You're welcome.
All right.